Hi guys, today's video is about momentum. I'm going to be explaining what momentum is, and I'm going to be showing you some random examples of how momentum is used in everyday situations. It's going to be great. What is momentum exactly? Momentum is a quantity of motion of a body, of a moving body, and it's a product of the body's mass and the body's velocity, which is moving at. So what is the equation for momentum? It's not that hard.
At this moment, Zaid realized he screwed up.
mv minus mu. The conservation of momentum is basically when the momentum before the collision is equal to the momentum after the collision. So it could be described as P1 plus P2 before the collision is equal to P1 plus P2 after the collision.
So the equation is P is equal to m times v. And P is the momentum, m is the mass, and v is the velocity, as you can see right there. So now I'm going to give you an example of where to use this equation to find the momentum. So you have a ball of 5 kilograms, and its speed is known to be 6 meters per second. So we know if we can use the equation P is equal to m times v, we can insert some of our values and find the momentum, which is P. So we know that P is equal to mass times velocity. And what's our mass? As I said, it's 5 kilograms. So you can do 5 kilograms times by the speed, which is 6 meters per second. 6 meters per second. Now, we know that we can use a calculator, or if you're good enough, you can find the answer in your head. So what's 5 times 6? Since I'm incapable of doing that in my head, I'm going to use a calculator to show you right there. 5 times 6 is equal to 30. So the answer will be 30 kilograms per meter second. Since you have to add them, put the units together. So this is the units for momentum. Momentum units. And then we have the value of momentum, which is 30 in this case.
So I'm going to give you a different example. So we're going to have two different balls of two different masses, and this mass is going to be 3 kilograms, and this is going to be 4 kilograms. And let's assume that the 3 kilogram ball has an initial velocity of 5 meters per second, and it's heading towards the 4 kilogram ball, which is stationary, so it's 0 meters per second. And let's assume that after the collision, after the balls collide, the 3 kilogram ball loses some of its speed, and it becomes 3 meters per second. And it's still heading in the same direction. And this 4 kilogram ball is going to be of velocity v. So we don't know the velocity, and we're going to try to find it out. So I just kicked the ball, as you just saw, and the ball started to gain velocity as it started to move. And since there is a velocity, you can use the equation momentum is equal to mass times velocity to find the final momentum. And it's as simple as that. There are two different types of collisions: inelastic collision and elastic collisions. Elastic collisions are where all the energy is conserved. Inelastic collisions are where not all the energy is conserved. So some is changed to heat, some is changed to sound, and there's many other types. When two objects collide in an inelastic collision, they normally stick together.
So I thought back to calculus, way back to Newton and to Leibniz and to problems just like this. And just like that, when I had given up all hope, I said no. There's just one way to find that slope, and so now I will find the derivative of exposition with respect to time. It's as easy as can be, just have to take the x dt I will derive. I will derive. I will derive.
So, what are explosions? Explosions are when the momentum before the collision is equal to zero. Since nothing is moving, everything is stationary, everything has zero velocity. Now let's see what happens if you put an egg in a microwave. That right there was an explosion. That's because before the explosion, the momentum was zero. It had a mass, but the velocity was zero, which means momentum equals zero. However, afterwards, it exploded, and the shell pieces, they just shattered and they went everywhere and went different directions. So the velocity increased.